Students, remember that the phase velocity of the wave cannot be measured experimentally. We can measure the group velocity of the wave by experiment. According to the Broglie hypothesis, the material particle such as electrons may be assumed as group of waves or wave packet, which obtained by superposition of waves of different wavelengths or frequencies. Thus, by which velocity an electron in particle form is propagated through a medium is called particle velocity. Again, by which velocity an electron in wave form, actually the wave packet, is propagated through the medium is known as group velocity, not phase velocity. So, the group velocity and particle velocity must be equal. If v be the particle velocity and vg be the group velocity, then v equal to vg. We shall prove it for an electron as well as a free particle. Here we shall also see that the phase velocity of the wave is greater than the velocity of light in vacuum. That means Vp greater than C. Students, as you know, the energy of the particle E equal to h cut omega. Hence, dE equal to h cut d omega, and momentum P equal to h cut k. Hence, dP equal to h cut dk. Now, E by P equal to h cut omega by h cut k equal to omega by k, and this is the phase velocity of the wave. Hence, we may write Vp equal to E by P. Again, dE by dP equal to h cut d omega by h cut dk equal to d omega by dk. This is the group velocity of the wave. So, the group velocity equal to dE by dP. Again, the energy E equal to mc square and momentum P equal to mv. Due to theory of relativity, m equal to m0 by root over 1 minus v square by c square. In our discussion, we assume the particle is electron. Thus, E by P equal to mc square by mv equal to c square by v, and this is the phase velocity, or Vp into v equal to c square. This v is the particle velocity of the electron. Now, the relativistic expression for total energy of the electron is given by E square equal to p square c square plus m0 square c to the power 4. Differentiating this expression, we have 2e dE equal to 2p c square dP, or dE by dP equal to p by E into c square. Now p equal to mv and E equal to mc square. So mv by mc square into c square. This is the group velocity and v is the particle velocity. Thus we prove that the group velocity equal to the particle velocity. If we put Vg equal to V in this expression, we may write Vp into Vg equal to c square. From the relation between the group velocity and the phase velocity, we have Vg equal to Vp minus lambda dVp by d lambda equal to lambda square common, Vp by lambda square minus 1 by lambda dVp by d lambda equal to minus lambda square d lambda dVp by lambda equal to minus lambda square d nu d lambda, as Vp equal to nu lambda, or 1 by Vg equal to minus 1 by lambda square d lambda d nu, or 1 by Vg equal to d nu 1 by lambda. This is an important relation for this problem. Now, if E is the total energy of the free particle and V is the potential energy, then kinetic energy of the particle is equal to half mv square equal to total energy minus potential energy, or 1 by V equal to root over m by 2 into E minus V. From the Broglie hypothesis, we get lambda equal to h by mv. Putting the value of V in this expression, we get 1 by lambda equal to 1 by h root over 2m E minus V. Now we put the value of 1 by lambda in this expression, and we may write 1 by Vg equal to d d nu root over 2m E minus V by h equal to d d nu root over 2m h nu minus V by h, as E equal to h nu equal to m by root over 2m h nu minus V equal to root over m by 2 E minus V, and this is 1 by V from this expression. Thus we may finally write Vg equal to V, which means the group velocity associated with the free particle is equal to the particle velocity. Now we shall show that the phase velocity of the wave is greater than the velocity of light in the vacuum. For this purpose, we recall the previous expression E square equal to p square c square plus m0 square c to the power 4. Now E equal to h cut omega and P equal to h cut k, so we may write h cut square omega square equal to h cut square k square c square plus m0 square c to the power 4, and omega equal to Vp into k. So h cut square Vp square into k square equal to h cut square k square c square plus m0 square c to the power 4. And from this expression, we may calculate easily that Vp equal to c into 1 plus m0 square c square by h cut square k square whole to the power half. And from this expression, we see that Vp greater than c. That means phase velocity is greater than the velocity of light in the vacuum. Again, if we put the value of k, that is k equal to 2 pi by lambda, we get the expression of phase velocity as Vp equal to c root 1 plus m0 square c square lambda square by 4 pi square h cut square. Look at this expression. As phase velocity is greater than c, so the group velocity or the particle velocity always less than the velocity of light in the vacuum. Thus it is again proved that no matter can travel faster than the light. This expression shows that the phase velocity of the wave, mainly the Broglie wave, depends on the wavelength of the wave even in the vacuum. This behavior of the Broglie waves is different from that of the light wave, for which the phase velocity is independent of lambda in vacuum, which is shown in our previous section.